Imagine a borderless planet, and imagine a world where, regardless of your background, your age, your nationality, and your languages, that we're all working together to advance humanity. Now, I'm not just talking about Star Trek and the Federation after the Klingon truce. I'm talking about science fact that's better than science fiction. A long time ago, before I was born, all of the big nations in the world who had already had different space stations in space were looking to make their next big space station, and they were all working on it in isolation individually. So there was this magic moment in time where some of the engineers started talking to each other, and those talks led to friendships and led to more talks, and then led to an incredible idea for an international engineering standard adapters that you could put between all of these modules and then assemble them in space, a bit like Lego, to create out of the individual country' space stations one large international space station. So this idea came about, and they knew that it would have to be multinational, it would have to be stable enough to survive changes in government, changes in friendships, any elections, any diplomatic things that happened in more than 10 years, because the construction was foreseen to take more than 13 years, so that's your entire school life from reception to year 12 to assemble in space, and it had to be stable enough to survive all of that, as well as keep humans safe and then function as orbital science laboratories. So this concept came together, and then the first piece started being built. So Zarya module was launched from Russia in 1998. Zarya means sunrise, heralding a new era. And then very shortly after, the first American module called Unity was launched. And they connected together in space, first go. Hadn't even been tried out on Earth before. The engineers had worked together and fully trusted each other and had open communications, and it worked. And then more Russian modules went up, more American modules went up. Actually, a lot of the American ones were built in Europe. That was the level of trust between all of the parties that were involved around the world. And the European Space Laboratory went up, the Japanese Space Laboratory, the Canadian robotic arm, all connected together in space. The trusses, the solar panels, the relays, the radiators, all of the components to make the entire International Space Station. It finally was completed in 2011, with the final module brought up by the shuttle being a multi-purpose logistics module, and it even had internet. Really slow. It was connected via remote desktop in Houston, and it had about the speed of a 56k modem, so ask your parents and teachers how much fun that used to be. And now we've had successfully 19 years of continuous human habitation aboard the International Space Station. That's 19 years of unbroken, continuous human cooperation from a ton of different countries around the world and in mission controls in space, benefiting Earth. All of the astronauts from all the countries are able to launch and land Soyuz vehicles, so you can launch and land in vehicles from other countries as well, and all the launches are done since the last 7 years and continue to be done in Kazakhstan, in Baikonur, and Baikonur was the launch site of Yuri Gagarin as well, the very first human ever to leave space back in '61. We have now completed the entire ISS, including a really important component called the cupola. Now, this is the very large window that you get all the amazing photos and videos that the astronauts take, and on their rare days off, it's their favourite part to go and watch the Earth below. And we have a lot of astronauts in recent years, can't think why, who have taken incredible photos of Adelaide that I personally cherish. So here's one from Sergei that he took recently. The whole ISS, now that it's complete, is about the size of a footy field if you look solar panel to solar panel. The habitable modules where humans live and work, the vertical part that you can see in this photo, and that volume is about the size of a 5-bedroom house, with 4 bedrooms worth of that being science laboratories. So you have the European, the Russian, the Japanese and the US science laboratories. And we're working in those all the time, the crew and ground control in parallel for efficiency, plus remote control with the science teams. We're running about 200 different experiments across a lot of different fields at any given time. We're doing medical research, base science, lots of different things to advance humanity and to bring the benefits back down to Earth. For For the astronauts in space, a big part of their lifestyle, of course, is also food. Space food is much nicer than it used to be in the old days. It's really tasty, and we have space food labs across Russia and Japan and Europe, in Italy and France. And we have, and the United States, of course, as well, in Houston. So we produce a lot of different space food, and the astronauts get to taste it before they go, so they can choose their favourite dishes that they'd like to have during their mission. And then in Europe, we have a really nice extra program for bonus space food. So the astronauts can pick their 5 favourite dishes from their home country, and we'll get a chef from that country to come to one of the space food labs and turn it into real space food. We just made a new batch from Italy for Italian space food, and I was one of the first taste testers. It was amazing. Parmigiano melanzane, cioè, fantastico, really good. And we also, you know, if you're going up to space, that's great. So if you want to go up and function in microgravity, it's pretty nice, and you'll adapt to it really fast. But if you want to come back down to Earth again and you have your body work in a 1G environment, then you need to do countermeasures. So that's, at the moment, we have exercises that the astronauts need to do so that they keep their muscles and their cardiovascular system and their bone metabolism, etc., below the clinical horizon, and bring it back down to a plateau that's closer to the 1G level. So to achieve this, we have the astronauts exercise for about 2 hours every day. So that's about an hour on the bicycle or the treadmill, and then about an hour on the advanced resistive exercise device, which is like this all-in-one incredible gym machine. And thanks to those, the astronaut bodies stay quite healthy, and they're able to adapt back to 1G really fast. So crew nowadays can usually walk out of the Soyuz when it lands wherever in the remote desert in Kazakhstan, picked up by the search and rescue crew, who are Kazakh and Russian, but of course, you know, everybody around the world has full trust in the international partners who have all of their own different roles. And during the training as well, it's extremely international. So you'll find that the international crews train together, and they have a lot of trust and respect for each other. Once you're selected for a mission, you train together for about 2.5 years. And then you go up to space, and you have about 6 months together on the International Space Station, and then about 6 months of post-flight activities together. So it's about 3 years that you're training with your crew. They become your family, their families become your families, regardless of which country and culture and background that you come from. And the same is true between mission control. The trust that they have is implicit and extraordinary, and we have the same between crew and mission controls on Earth, and between all of the mission controls around the world. And there's not just Houston like the movies. So there are actually 5 mission controls. There's Houston, Huntsville, Munich, Moscow, and Scuba. We're representative of other ISS flight controls and science centres, of course, but we work extremely well together. So the Houston Centre, it's one of my photos when I was on console there. Houston takes care of the systems and the overall US planning and safety and the big picture from that perspective. Huntsville is in Alabama, and they're responsible for all of the science that goes on in the US Science Laboratory. Scuba, jumping over to Japan, takes care of all of the Japanese systems and payloads in the Japanese lab, as well as their external platform and their airlock that they can shoot out satellites into space and launch them from the ISS. Now in Moscow, they have a massive responsibility. They take care of course, the Russian Science Laboratory, Russian systems, all of the visiting vehicles, the reboosts, the refueling of the space station, debris avoidance maneuvers, and the attitude control. So you drop down a little bit each month with gravity, so you've got to reboost back up to maintain the orbit. The attitude control, which is the position, is actually taken care of by Houston, and they trust each other so much that they give each other remote control of each other's systems for the attitude and the altitude. Now, Europe, we're a bit more geopolitically, distributed, let's say. So the actual mission control is in Oberpfaffenhofen, which nobody wanted to say, so we call it Munich. And when astronauts call Munich, they're actually talking to myself or my colleague, and we are in Cologne on the other side of Germany. And then the ISS science centres in Europe are in about 7 different countries. But with today's technology, it doesn't matter if you are next to somebody upstairs, in the next building or across the ocean. We're very well interconnected. We communicate very openly. We're synchronised on the same timeline, and there's no secrets between us in mission control. We have really, really open communications. We know what we know and we know what we don't know. And that comes down to the phases of learning. So when you don't know something and you don't know that you don't know something, you have unconscious incompetence. You completely don't know about this concept whatsoever, but then you learn about something new. So now you have conscious incompetence. You know that you don't know. But then you study it and you practice it, and it's tough, but you train, and now you've got conscious competence. You know that you know, but that's because you've studied and you've worked hard to know it. And you can go beyond that, of course, and have unconscious competence, and that's when something's so second nature you don't even think about it. In English, I would say the small green tree. Why did I put the adjectives in that order and not say green small tree? It sounds weird. It's just something that you know is second nature. So in mission control, we're in the middle. We know what we know, and we know what we don't know, and we openly and honestly say that, and that is a mandate that we have. It's really important, and that's counterintuitive to a lot of society where you want to pretend that you know something and pretend that you're good at something, but we're responsible for people's lives. We trust each other, and we will very openly say what we do and don't know and speak up at the correct time. There's no shyness and there's no shame whatsoever in that, and that is our responsibility and mandate. So with mission control mates, it's really great also being able to meet up with them around the world. We talk to each other on the loops all the time, so we know each other's voices, and then when you finally get to meet in real life, doesn't matter where people are from, we all have the same nerdy language, and it's so nice to put a face to the voice and be like, oh, that's what that voice looks like in real life. We have genuine friendships as well with mission control all around the world. We talk to each other very openly, as mentioned. We usually have our counterparts, so the people who talk to the astronauts in space, that's my role now. And I'm called Eurocom, but we have a name just depending on the geography of which mission control we're in. So Capcom is Houston, Paycom Huntsville, Eurocom in Europe, JCOM in Japan, Glovny in Russia. It's a slightly different word in Moscow. So we had one incident where we were doing a comms check. Normally we use satellites, it's really fast, it sounds great, and you don't notice any delay. But we also have a backup radio system. So we were going to do a backup on a test to check the audio on the backup system. And normally we just count up and down to 10. And the German astronaut calls down about 5 minutes before and says, all right, well, instead of counting to 10, everybody tell a joke. So that's fine. So Capcom, Paycom, JCOM, Glovny and I are chatting on our private loop. And Capcom says, okay, Munich, instead of doing a joke in English like the rest of us or in Russian, do it in your native language. And I'm like, you mean German? And he's like, yes. Do it in German, please, for the German astronaut. And so with 5 minutes notice, and I have been on console for emergencies, for cautions, for warnings, for alarms, for space debris avoidance. My most terrifying moment on console was being asked with 5 minutes notice to tell a joke in German to a German astronaut. So the Belgian flight director and I, no native speakers of German were on console at that time. We scrambled to find something. I will relay it to you now with a prior caveat that it's a terrible dad joke, but it had the word kangaroo in it, so it was funny. And it was, kann ein Känguru hoher dann ein Haus springen? Ja, weil ein Haus nicht springen kann, which roughly translates to, can a kangaroo jump higher than a house? Yes, because a house can't jump. It is up there in the dad joke levels. But the German astronaut thought it was hilarious because it was also the first time he'd heard me speak German. Now, we have a few Australian schools' involvement on the space station, and whenever that happens, I'm always cheering for it. There's a robotics competition where you can submit code, it goes in a simulator, battles out against other schools around the world. In the last 2 years, we've had Australian high schools make it to the grand final, so their code's gone up to the space station, astronauts loaded onto physical inside satellites, and then the satellites battle it out on the station, and in mission control I'm there cheering very loudly for Australia. In Australia we have amazing opportunities now with the new Australian Space Agency, and That's going to grow and grow in the future, and a lot of the activity is happening right here in Adelaide. We have the hub on Lot 14 with the Space Agency, with a satellite control centre, with a mission discovery centre for student education and teacher education, as well as the SmartSat CRC. And we have industry and students and companies and the agency really uniquely together in the same place in Adelaide, all working together and interfacing, of course, with the other states. And the Australian Space Agency has gone from strength to strength. It's only been around for a year. It already has international partnerships with lots of different countries and companies, and there's going to be so many stellar opportunities in the future, and a lot of them will be right here in Adelaide that you can look forward to. So, thinking about that and thinking about the Space Agency, I really love the logo that Australia came up with. At first glance, you might think that it just looks like a map of Australia, but it's actually Indigenous Australian constellations. So the First Nation of Australia were the original astronomers and have been the oldest astronomers on the entire planet. They knew how to look at the stars and how to interpret them according to the seasons and how to plan. So the map is actually composed of Aboriginal star constellations that are then brought together to form the Australian Space Agency logo. Coming back to the space station, it truly transcends politics. There were 2 astronauts that were up in space together for an entire year recently, and they said that there's no borders in space. Whatever's happening on Earth, we don't discuss it because we're colleagues, we're professionals, and we're friends. And that is exactly how it is in space, in the International Space Station, and with Mission Control. It's the only project that truly does transcend politics. And you look down from the space station, and from our views in Mission Control, we can see up to 16 sunrises and sunsets every single day. We see the entire Earth. It looks beautiful, it looks united, it looks fragile. You can see the International Space Station from Earth with your own eyes. You get alerts on your phone, you can go out at night. It'll tell you about 5 minutes before you can go out, and you can see the space station passing overhead. It looks like a shooting star which goes across the entire night sky from horizon to horizon, and you can very clearly see it with just your own eyes. Take your mates out, take your friends, talk to randos that happen to be nearby, and tell them what you know now about the incredible international crew that's working together on the ISS to benefit humanity, as well as the international interconnected mission controls that are operating 24/7 on Earth. And while it is amazing and truly does transcend politics and everything, it is the only unique project like that on Earth right now, and it's not going to be around forever. So what projects, what ideas could you imagine and could we come up with that are like the ISS, that are truly borderless, and that could transcend and really unite the world in the future? Thank you.